Hello everyone. This video will review test 5. There are 26 multiple choice questions. They are very similar with the 26 sample examples here. Number 1, find the square root of 25. This notation, this expression represents the principal square root of 25. It represents one number, a positive number. The positive number whose square is 25. So what is square root of 25? Which positive number has a square 25? Is 5, right? Any question about number 1? Number 2, we need to find a negative square root of 9. This expression represents the negative square root of 9. We know any positive number has 2 square roots. One is principal, the other is the negative. So this notation represents the negative square root of 9. It must be a negative number. Which negative number has a square equals 9? Yes, so the result is a negative 3. Number 3, we need to find square root of negative 16. Square root of negative 16. Let's think about negative 4 to the power of 2 is a positive 16, right? Yeah. Remember, if the radicand of a square root is negative, then the square root is non-real. Remember that? Yeah. So number 3, you choose non-real. If the radicand of a square root is negative, then the square root is non-real because there's no real number whose square is negative 16. Yeah, no real number whose square is negative 16, right? Yeah, so what is that? Radicand is the quantity underneath the square root symbol, a radical symbol. Yeah, if the radicand of a square root is negative, then the square root is non-real. Number 4, we need to find the cube root of 8. The index here is 3, so the radical is a cube root. We know the cube root of a positive number is positive. The cube root of a negative number is negative. The cube root of 0 is 0. Cube root of 8 would be a positive number. Which number whose cube is 8? Which number whose cube is 8? 2, yeah. So the result is 2. Cube root of 8 is 2, exactly. Very good. Number 5, we're looking for cube root of negative 27. By the way, cube root of a negative number is a real number, is a negative real number. Square root of a negative number is non-real, but the cube root of a negative number is well defined. Yeah. It represents a number which must be negative, whose cube is negative 27. So which negative number has a cube equals negative 27? What is that? Negative 3, exactly. So the result is negative 3. Yeah, negative 3 has a cube, negative 27. You can try use your calculator. Negative 3 times negative 3 times negative 3 gives you negative 27. That is number 5. Any questions so far? Number 6. If x squared equals 81, find the value or values for x. We know x squared equals 81. We need to solve for x. Which number whose square is 81? Which number whose square is 81? 9, only 9? Can we find another number whose square is also 81? Negative, right? Yeah. So we have 2 solutions here. positive, negative 9. Yeah, plus minus 9. We can actually apply square root property for solving this problem. Square root property tells us if x squared equals a, then x equals plus or minus square of a. This is also consistent with the fact or conclusion we learned before. A positive number has two square roots. Yeah, any positive number has two square roots. The principal square root and the negative square root. For 81, it also has two square roots. One is a principal, the other is a negative. So there are two numbers whose square is 81. Yeah, we should choose plus minus 9. The answer you should choose is plus minus 9. Yeah, we have two numbers. Both of them have square equals 81. Number 7, simplify square root 20. Simplify square root 20. The radicand of this square root is 20, right? The radicand of the square root is 20. Is 20 a perfect square? If no, we're going to put 20 on a big L. Remember, we have a procedure for that. We put 20 on a big L. 20 is even, so divided by 2, we have 10. 10 is even, divided by 2, we have 5. So we are able to write 20 as 2 times 2 times 5. 2 times 2 is 2 squared. So the radicand, we put the radicand as, the radicand 20 can be written as 2 squared times 5, right? Yeah. Once we prime factor the radicand 20, we can write a radicand as 2 squared times 5. Could we move the 2 in red outside the radical? Could we move the 2 in red, the base 2 in red outside the radical? 2 has a square on the shoulder, right? The square cancel the square root. So 2 will be released. Remember that? Yeah, 2 will be released outside the square root. 5 will stay because the 5 has no square to cancel the square root. Does that make any sense? That's how do we simplify square root of 20. We write 20 as 2 squared times 5. Because 2, the base 2 in red has a square on its shoulder. The square cancel the square root. 2 could be released outside the radical, right? You remember we say 2 has a $2 ticket, so 2 could be released from the, containment. 5 remains because 5 has no square on its shoulder. Any questions? Does that make sense? Okay, so that is number 7. Let's move to number 8. Number 8, we need to simplify a negative square root. Negative square root. Negative square root of 80. Yeah, number 8, we need to simplify negative square root of 80. Yeah, the negative sign, we will just keep it the whole time. The key is to simplify 80. Radicand, the radicand of this square root is 80. Is 80 a perfect square? We tried 1 square, 2 square, 3 square, all the way to 20 square, right? 80 is not a perfect square. If it's not a perfect square, we put it on big L. 80 is divisible by 2. Divided by 2, we have 40. 40 divided by 2, we have 20. Divided by 2, we have 10. Divided by 2, we have 5. So you see, actually, we can write 80 as 4 times 4 times 5, right? Or 4 squared times 5. Yeah, we can write a radicand 80 in the square root as a 4 square, as a 4 square, 4 square times 5, times 5. I want to write a square as blue. Yeah, again, because the base 4 has a square on its shoulder, we are able to release 4 outside the radical. Then the expression can be written as negative times 4 times the square root of 5. Because 4 has a blue square on its shoulder. The blue square cancels the square root, so 4 is released from the radical. The answer is a negative 4 times root 5. So far, so good? Any questions? If you don't say anything now, just move on, okay? Yeah, I'm making the video, so ask questions if you have any. Number 9, simplify square root of x to the power of 13. All the variables in this section, in this chapter, are assumed as positive. We need to simplify square root of x to the power of 13. The radicand is a monomial with variable x. The exponent on x is 13. Is 13 even or odd? Even number or odd number? Yeah, it's odd, right? So we're going to write 13 as 12 plus 1. Yeah, we're going to write 13 as 12 plus 1. And then write 12 as 6 times 2. Then x to the power of 13 would be x to the power of 12 times x to the power of 1. We use the formulas we learned from chapter 4. X to the power of 13 is x to the power of 12 times x to the power of 1. And x to the power of 12 can be written as x to the power of 6 and then square. Power rule. X to the power of 6 and then to the power of 2. 6 times 2 is 12. Power rule. Then the radicand of the square root, which is x to the power of 13, can be written as x to the power of 6 square times x. Let's pause here and ask a question. Do you see what's going on here? Do you have any question? Yeah. So anybody, everybody. So far so good? Okay. So could we move x to the power of 6 outside the radical? Yeah, because x to the power of 6 has a square on its shoulder. We are able to move it out. X to the power of 6. And under the square root, we still have a factor, which is x, remain under the radical because x has no square on its shoulder to cancel the square root. And this is the final answer. Okay? Any questions? Number 9. Number 9, simplify a square root of a monomial. Coefficient is 1. The exponent on the shoulder of x is odd number. Number 10, the exponent on x is even. So let's see. Number 10. Number 10, we need to simplify square root of x to the power of 14. 14 is even, right? Yeah. 14 is even, that means 14 can be written as 2 times 7 or 7 times 2. Then x to the power of 14 could be written as x to the power of 7 and then to the power of 2 by the power rule. X to the power of 7 and then to the power of 2 by the power rule is x to the power of 14. We multiply the two exponents. 7 times 2 is 14, right? 7 times 2 is 14. Yeah. So we're going to write a radicand x to the power of 14 as x to the power of 7 and then to the power of 2. Yeah, because of the base x to the power of 7 in red has a square on its shoulder. The square will cancel the square root. The result is x to the power of 7. And nothing left under the radical. Yeah, the only base x to the power of 7 is released, so nothing under the radical. Or you can say 1 is under the radical, but square root of 1 is 1, so we do not have a radical anymore in this case. The square in blue cancel the square root. The result is x to the power of 7. Number 10, if the exponent is even number, that's how do we deal with it. Any questions? Number 11. Number 11, we need to simplify this square root. The radicand of the square root is 27 times x squared. X here is a positive. Radicand is a monomial. Radicand here is a monomial. This monomial has numerical part, 27, variable part, x squared. We're going to deal with them separately. In order to simplify the square root, we deal with the coefficient and the variable part separately. 27 first. 27 is the numerical part of the radicand. Is 27 a perfect square? If not, put it on big L, right? Yeah, we know 27 is divisible by 3. Divide 27 by 3, we have a 9. 9 is 3 times 3. So 27 is 3 times 3 times 3. We can write 27, the blue, the numerical part, as 3 square times 3. Yeah, 27 can be written as 3 square times 3. So that's the numerical part. The variable part, x squared. Exponent 2 is even. So actually, x squared is just the x to the power of 2, right? Yeah. X squared, the variable part itself is a perfect square. X squared is just the x squared. So we write the base x in red, exponent 2 in blue. Same rule applies. Whatever the base has a square on its shoulder are able to be moved outside the radical. So we have 3 is out, x is out, right? Under the square rule, we have 3. So the result is 3x times root 3. The result is 3x times root 3. Questions? Number 12. Number 12 is very straightforward. I will give you the formula for the distance between 2 points. All you need to do is to apply the formula, plug in, and operate. Let's look at number 12. We need to find the distance between the pair of points. The 2 points are 1, -2. The other is 7, -4. Yeah, we have 2 points. This point, I think, in which quadrant is point? Just something extra. 1, -2 is in quadrant 1, 2, 3, or 4. One, -2 in quadrant 4, right? 7, -4 is also in quadrant 4. Yeah. So we need to find the distance between the 2 points. We have a 3-step procedure to do that. First step, label the 2 points, x1, y1, x2, y2. So x1 is 1, y1 is -2, x2 is 7, y2 is -4. Step 2, copy the formula. I will give you the formula, so no problem with that. Formula D equals square root x2 minus x1 square plus y2 minus y1 square. Step 3, plug in and operate. x2, what is x2? Seven minus x1, what is x1? Yeah, to the power of 2. plus, what is y2? -4 minus y1. y1 is -2, so minus -2. Yeah, be very careful with the sign. 7 minus 1 is 6, so we have a 6 square here. -4 minus -2. Minus -2 is the same with plus +2, right? So -4 plus 2 here. 6 square. -4 plus 2 is -2. Yeah, -2 square. What is the 6 square? 6 square, 6 times 6. Yeah. What is the -2 square? +4. Yeah, +4. Be very careful when you handle numbers with a sign. So the radicand, 36 plus 4, 40. Yeah, we need to simplify square root of 40. 40 is not a perfect square, so put it on big L. Divide by 2, divide by 2, 5. So we can write square root 40 as the square root of 2 square times 5. 2 can be removed. 2 can be moved outside the radical, so we have 2 outside times root 5. So the answer is 2 times root 5. The distance, hold on. Oh, yeah, you are right. My bad. So this is 10, 2, 5. So that is 4 times 10. 4 times 10 here. The factor here left underneath the square root is 10. Yeah, the answer is 2 times the square root of 10. Yeah, apologize for that. So when we prime factor 40, we have 40 equals 2 times 2 times 2 times 5. So that is 2 square times 10. 2 square times 10. Then that is 2 times square root of 10 after simplifying. The result is 2 times square root of 10, the distance between the 2 points. Any question about number 12? Number 13. Find the equation of a circle satisfying the given conditions. Number 13 is also straightforward because I will give you the formula. All you need to do is to apply really straightforward application of the formula. Number 13, you are given a circle centered at 0, -6. So the center of the circle is given. The radius of the circle is also given. Yeah, so that means h is 0, k is -6, r, radius r, is square root of 5. H, k is the center. The formula of a circle is x minus h to the power of 2 plus y minus k to the power of 2 equals r squared. And let's plug in. Let's plug in. We have x minus h. What is h? What is h? 0, right? Yeah. Minus 0 to the power of 2 plus y minus k. What is k? K is a -6, so minus -6. R squared. R is root 5. X minus 0 is x, so we have x squared. Y minus -6 minus negative is plus positive, y plus 6 to the power of 2 equals root 5 to the power of 2. Root 5 times root 5 equals what? 5. Here we go. That's the result you are looking for. A, B, C, D. The equation of the circle centered at 0, -6 with the radius root 5 is this one. Yes, straightforward application. Number 14. Number 14 is very straightforward. We need to simplify 2 root 5 minus 7 root 5. This is a subtraction of 2 square roots. The 2 square roots are like radicals. Remember, we cannot combine radicals if they are not like radicals. How do we define like radicals? Two radicals are like radicals if after simplify, they have exactly the same radical part. In our expression, you see, the first radical expression has a radical part root 5. Coefficient is 2. The second radical expression has a radical part root 5. Coefficient -7, right? Yeah, so that is two like radicals. Yeah, they are two like radicals. We combine like radicals by combining their coefficients. Their coefficients are 2 and -7. 2 and -7 multiplied by root 5. Multiplied by root 5. And what is 2 minus 7? -5. Very good. So 95 root 5. 95 root 5. So that's the answer. Yeah, the answer you are going to choose from A, B, C, D is a -5 root 5. Any question about number 14? If not, let's move to -15. -15 simplify the expression square root of 3x plus 8 times square root of 27x. Yeah, this problem a little bit challenging. We are adding two radicals. We are adding two radicals. But you can see the second one is not simplified yet. The first radical is simplified, but the second one is not. So we need to simplify the second radical. We copy square root 3x, copy 8 here, and we need to simplify 27x. 27 is 3 times 3 times 3. So we can write 27 as 3 squared times 3x. Yeah, again, you see how many times we have applied the rule to simplify a square root. Whatever the base which has a square on its shoulder can be moved outside the square root. So we have 8 times 3 here, and multiply by square root of 3x. Multiplied by square root of 3x. 3x has to stay underneath the square root because 3x has no square on its shoulder. And that gives us square root 3x plus 8 times 3, 24. And then we can combine them. You see, we have 1 square root of 3x here. We have 24 square root of 3x here. Combine their coefficients, 1 plus 24, 25. That's the final result. Okay, questions? Number 16. What's the conjugate for square root 3 plus square root 5? Conjugate is square root 3 minus square root 5. Yeah, the definition is right here. Square root of a plus square root of b and square root of a minus square root of b are conjugates. All right, yeah, that's very straightforward. Number 17. We are multiplying two binomials, and the two binomials are conjugates. Square root of 2 plus square root of 3 times square root of 2 minus square root of 3. In the class, we have a formula. Square root of a plus square root of b times square root of a minus square root of b equals a minus b. We proved this formula in the class. So we are going to apply this formula for number 17. Square root of 2 plus square root of 3 times square root of 2 minus square root of 3 equals 2 minus 3, which is -1, right? Yeah, so very straightforward if you know the formula. I will give you the formula during the test, so just apply it. Also in number 17, for the review, I give you two methods. Solution number 1, solution number 2. You can choose either method you feel you like more. Yeah, either method, both methods are good methods. Number 18. Number 18, I also give you two different solutions. I'm going to use the second solution. The formula I'm going to apply is square root of a plus square root of b times square root of a minus square root of b equals a minus b. The problem we are going to simplify, the expression we are going to simplify is square root of a plus 3 times square root of square root of 2 plus 3 times square root of 2 minus 3. We can write 3 as root 9, could we? Could we write 3 as square root of 9? Then the expression becomes square root of 2 plus square root of 9 times square root of 2 minus square root of 9. And we apply the formula. The formula right above it here. We have the product equals 2 minus 9, which is -7, right? Yeah. So you can see in the review, I give you two different solutions. They apply different formulas. Just choose the one you feel more comfortable. Any questions about number 18? Number 19. Find the square root of 2 times square root of 3. Very straightforward, number 19. Formula you need to use for number 19 is the square root of a times square root of b equals square root of a times b. Both a and b are positive. Then square root of 2 times square root of 3 is the square root of 2 times 3, which is the square root of 6, right? Very, very straightforward, very simple. Number 20. What's square root of 2 times square root of 2? We practice this in the class, right? Square root of 2 times square root of 2 is 2. Square root of 3 times square root of 3 is 3. Square root of 5 times square root of 5 is 5, and so on. Square root of star times square root of star is a star. Yeah. So I don't worry about too much about number 20. Square root of 2 times square root of 2 is 2. Number 21. Multiplication of two radical expression. Let me write number 21 here. Square root of 3 minus 2 times square root of 7 plus 5. We are going to apply FOIL to process this product. First times first, plus outside times outside, plus inside times inside, plus last times last. We fill in the 8 blanks. First, root 3, root 7. We understand what is the first, right? Yeah, the first terms in the two parentheses. First. Outside. Those two terms are on the outside. So we have outside times outside, root 3 times 5. Inside. Those two terms are on the inside. So inside times inside is -2 times root 7. Last. What's the last term in the first parenthesis? What's the last term in the second parenthesis? It's a -2 and 5, exactly. So this is the last. So it's a -2 and 5. And let me double check. First, outside, inside, last. Yeah. And we simplify in the next step. Root 3 times root 7. 3 times 7, 21. So square root 21. Plus 5 times root 3. Minus 2 times root 7. -2 times 5, -10. And look at those four terms. None of them are radicals, so that's the simplified form. So the answer you're going to choose is this expression. Any questions? Number 21, FOIL. Number 22, rationalize the denominator. Number 22, we have a radical expression, which is 1 over square of 3. The denominator is root 3. An expression is not simplified if it has a if it contains a radical. So in order to simplify this expression, we need to remove the radical from the denominator. We call the process as rationalize the denominator. In order to rationalize the denominator, we need to identify the denominator. What's the denominator? Root 3, right? What's the conjugate of the denominator? Conjugate of the denominator is itself. Is also root 3. Okay, also root 3. Yeah. The conjugate of the denominator is also root 3. So we are going to multiply both top and the bottom by root 3. Yeah. This way you will see the denominator becomes 3. Numerator becomes root 3. And that's the answer you're going to choose. In the answer, the denominator has no radical anymore, so it's simplified. Yeah. Let me repeat the process. Rationalize the denominator. You need to identify the denominator first, right? Yeah. If the denominator is one single square root, the conjugate of the denominator is itself. In this case, denominator is root 3. So the conjugate is root 3 as well. We multiply the numerator and the denominator by root 3, the conjugate, to rationalize the denominator. Number 23, rationalize the denominator. In this case, the denominator is a binomial. Let's see how do we apply the process to rationalize the denominator. The denominator is three minus root 2, right? Yeah. And what's the conjugate of the denominator? 3 plus root 2. Yeah. So we're going to multiply both top and the bottom by the conjugate 3 plus root 2. 3 plus root 2. Okay? And the denominator, I can write the denominator as root 9 minus root 2 times root 9 plus root 2. Because the 3 is the square root of 9. Numerator is 5 times 3 plus root 2. Equals denominator root 9 plus root 2 times root 9 minus root 2 is 9 minus 2, right? Yeah. Numerator, we distribute 5 times 3, 15. 5 times root 2, 5 root 2. So we end up with 15 plus 5 root 2 all over 7. Any question about number 23? We used this formula, root A minus root B times root A plus root B is A minus B. We use that formula. So that's the reason I rewrote 3 as root 9 in order to apply the formula. Number 24, also rationalize the denominator. Number 24. The denominator is a binomial and it contains 2 radicals, 2 square roots. Same thing. Denominator is root 2 plus root 3. Root 3. Conjugate of the denominator. What's the conjugate of the denominator? Very good. Root 2 minus root 3. So how do we use the conjugate? We're going to multiply both top and the bottom by the conjugate. Multiply both top and the bottom by the conjugate. and see what happened after that. Numerator, root 2 minus root 3. Denominator, root 2 plus root 3 times root 2 minus root 3. 2 minus 3. Yeah, again, we use the formula right here. We use the formula right here. 2 minus 3 is a negative 1. And that is equal to root 2 over negative 1 plus negative root 3 over negative 1. Root 2 over negative 1 is a negative root 2. Negative root 3 over negative 1 is a positive root 3. So the result is negative root 2 plus root 3. Any question about negative 1 here? Minus negative 1 is the same with multiplied by negative 1, right? Divided by negative 1 is the same with multiplied by negative 1, right? So you basically change the sign, change root 2 to negative root 2, change negative root 3 to positive root 3. That's what happened here. So that is number 24. Any questions? Number 25. Yeah, the last two questions are solving equation, radical equation. Number 25, let me copy it. Is square root x plus 1 equals 5. Square root x plus 1 equals 5. Okay, let's solve the equation. We have only one radical in the equation, which is the square root, and it is isolated on the left already. So we're going to square both sides. In order to solve for x, we need to get rid of the square root. In order to get rid of the square root, we square both sides. Then the left-hand side becomes x plus 1, because the square reverses the square root. And on the right, 5 times 5, 25. Solve for x, minus 1, minus 1. We have x equals 24, right? What's the last step for solving a radical equation? Very good, check. Yeah, we need to remember to bring the proposed solution back into the original equation to see if the original equation would be satisfied. So we plug in square root x is 24. 24 plus 1 equals 5. Square root 25. 5 equals 5. Yeah, turns out 24 is the actual solution. So the answer you're going to choose is this. Yeah, you see the braces, that is a set. The solution set is a set containing one solution, which is 24. All right, that's the answer. That's the answer you need to choose from A, B, C, D. Last problem, number 26. Let me write it here. Square root of x plus 5 equals 3. Number 26. Number 26. We need to solve this equation, radical equation. How many radicals do we have? 1, right? Yeah. We need to isolate that radical first. Isolate that radical first. In order to do that, we minus 5 from both sides. Positive 5, negative 5 cancel each other. So we have a root x equals 3 minus 5, negative 2. Okay. Look at this equation. Square root of x equals negative 2. Do we have to continue? Do we need to continue? Why not? Because square root of x is not possible being negative 2, right? Yeah. In real number set, we do not have such a real number whose principal square root is negative 2. So that is a contradiction. Yeah, the equation itself is a contradiction. The solution set of the equation is empty, means it has no solution because there's no such real number whose square root is negative 2, right? Whose principal square root is negative 2. So number 26, the equation has no solution.
都洗不水。